Dear students, myself Dr. Mallikarjun S. Biradar, Assistant Professor in Mathematics, Government First Grade College, Basavakalyan. The 51st session of Graph Theory 2 is some results on digraphs. So we will see what are the results, the basic results on digraphs in this session. Again, to discuss the results, we should have the basic ideas of digraphs, what we have discussed so far. In particular, we have discussed about walk, path, cycle. So those concepts, so we are using those concepts and the results are based on those concepts. Okay. So let me recall once again what we mean by walk, path and cycle. Okay. The concepts of walk, path and cycle are taken from the undirected graphs, except that the directions of arcs must agree with the direction of the walk. So similarly, so the directed walk, it is an alternating sequence of vertices and edges, isn't it? So that already we know, right? It is an alternating sequence of vertices and edges. It implies W, if I say it is a walk, then it will be V0, E1, V1, E2, V2 and so on and so forth, En, Vn, where the arc EI begins at Vi minus 1 and ends at Vi. The arc EI begins at Vi minus 1 and ends at Vi. The length of the walk will be the number of edges that occur in it. So that will be the length of the walk. A closed walk has the same initial and final points, or you can say initial and terminal points. Okay, so that will be a closed walk. So these are the ideas already we have discussed in the previous session. So without wasting much more time, directly we will move on to the results. Okay, next, and some more another idea, that is spanning walk. The spanning walk contains all the vertices of the digraph. It is called a spanning walk. For example, in case of a graph, Hamiltonian cycle is one example of a spanning walk. Okay, Hamiltonian cycle containing all vertices of the graph. Similarly, semi-walk, as I said, from Bangalore to Mysore, but you are not reaching from Bangalore to Mysore, though the target is from Bangalore to Mysore, in between. Okay, so you are coming back, though you are not coming back, you are reaching somewhere at in between Bangalore and Mysore. Okay, so that will be a semi-walk. Semi-walk in a directed graph is a walk in the corresponding undirected graph, and it is not a directed walk. Okay, so now we will see some basic results. Not necessary to prove the results, of course. These are the fundamental results, we can say. The necessary and sufficient conditions for a directed graph to satisfy each of the three kinds of connectedness. What are the three kinds of connectedness? One is weakly connected digraph, another one is unilaterally connected digraph, and the third one is strongly connected digraph. Okay, if you see those three connected digraphs, what would be the result? Okay, so it will be a theorem. If D is a finite directed graph D, then D is weak if D has a spanning semi-walk. D is unilateral if D has a spanning walk. See the difference? Semi-walk, that will be a weak digraph. Spanning walk, from one place to another place, traveling or reaching all other vertices in between. Okay, spanning walk. And D is strong if and only if D has a closed spanning walk. Closed spanning walk. Whenever it is a closed walk, you will get two paths, U to V as well as V to U. So this is the result. Okay, whatever we have discussed, the concepts, there only we come to know these ideas, but it is in terms of a theorem. Okay, it is mentioned in terms of a theorem, no need to prove. Now source and sink, already we have discussed these concepts, but again we are recalling because we are considering one theorem, one result based on source and sink. A vertex with 0 in degree is called a source. Let me recall, a vertex with 0 in degree is called a source, and a vertex with 0 out degree is called a sink. So that already we have discussed, just I have recalled once again. Now consider a theorem based on the source and the sink. If a finite digraph does not contain a directed cycle, if a finite digraph does not contain a directed cycle, then D contains a source and sink. So this is the theorem. Okay. So let us prove or try to prove this theorem. So what we have to consider, let V0, V1 and so on and so forth, Vn be the longest path in the digraph. Suppose there are n vertices including V0. Okay, so we consider a longest path V0, V1 and so on and so forth, Vn. The last vertex contains in degree only. Definitely last vertex, the end vertex in a path. Last vertex is called an end vertex. Even initial vertex is also end vertex, but in case of direct end vertex, what would be the in degree? 1. Okay, in degree. So therefore, what I am going to say is that the last vertex contains in degree only 1. Okay, that is the only one or only the in degree for the last vertex. Therefore, Vn is a sink. Definitely Vn is a sink whose in degree is 1. Okay. Source and sink already we have recalled. A vertex with a 0 in degree is called a source, and a vertex with 0 out degree is called a sink, because only in degree is there but out degree is 0 in case of end vertex. So that's why the last vertex Vn will be a sink. If Vn is not the last vertex, suppose if Vn is not the last vertex, if possible, extend the path to V. If V exists and it is different from V0 or V1, V2 and so on and so forth, Vn, then what happens? Then the length of this path will exceed the previous path, isn't it? Definitely. Then what happens? Then you will get a contradiction. Already you said it is the longest path, but you are getting it has been extended to V. It implies this is a contradiction to the assumption that the V0, V1, Vn is the longest path. So therefore, V will not be different from V0 or V1 or Vn. It implies V is amongst one of the vertices of V0 to Vn. If V is any one of the previous points, V0, V1 and so on and so forth, Vn minus 1, then we get a cycle. This cannot be accepted because it is given in the data that a directed cycle does not exist. Therefore, the path does not go beyond Vn. It implies the digraph contains the sink Vn. Sink Vn. Similarly, we can prove that V0 is the source. How we have proved Vn is the sink. In the same fashion, we will prove V0 is the source. Therefore, D contains a source and a sink. So, what is the statement of the theorem? If a finite digraph does not contain a directed cycle, then D contains a source and sink. So, this is how we have proved the result. Okay, let me consider a note. The above theorem can also be stated as follows. The same theorem which we have discussed, you may state in another way also. How you can say an acyclic, there is no cycle means it is an acyclic. An acyclic digraph has at least one point or one vertex of in degree 0 and at least one vertex of out degree 0. It is very obvious because there is a sink and there is a source. So what you can say, same theorem you may represent in another form. How? An acyclic digraph has at least one point of in degree 0 and at least one point of out degree 0. So you can write this statement in a different form. Okay. So now in this session, what we have discussed, we have recalled the concepts of walk, path, cycle, and we have recalled the concepts of weakly connected digraph, unilaterally connected digraph, and strongly connected digraph. And we took some results based on the weak, unilateral, strong in terms of semi walk, path, cycle, like that. Okay, based on those we have considered one result. Then we took another result based on the source and sink. So with this, I think these are the reference books for your reference. So with this, we conclude this session, because we have considered two important or basic fundamental results. Okay. So therefore, what we can say, these are the reference books, and with this we conclude this session. Thank you.